In the dark depths of the ocean, an extraordinary world thrives, a realm of bioluminescent displays and bizarre life forms. Hydrothermal vents release superheated, mineral-rich water, creating oases of life in an otherwise inhospitable environment. Here, over 2,000 meters deep, life showcases astonishing resilience and adaptability. The pressure is staggering, over 300 times that of sea level, and temperatures can exceed 400 degrees Celsius. Yet, vibrant ecosystems flourish. Eyeless creatures glide through a landscape of black smokers, chimneys spouting shimmering smoke. Bioluminescence flashes illuminate an intricate web of life. Tube worms, some over 3 meters long, anchor themselves to vent structures, feeding on chemicals spewing forth. Lacking sunlight, they harbor symbiotic bacteria that convert toxic substances into energy through chemosynthesis, challenging our understanding of life. As we explore deeper, we see diverse communities around the vents. Giant clams and vibrant anemones coexist amidst harsh conditions, while crabs and shrimp rely on their environment's unique chemistry for survival. New species continue to be discovered, expanding our knowledge of biodiversity in these extreme habitats. However, these ecosystems face significant threats from human activities like deep-sea mining, climate change, and pollution. Conservation is crucial to protect these fragile environments. The lessons from hydrothermal vents remind us of life's delicate balance and the importance of global biodiversity. As we explore the deep sea, we commit to preserving these secrets for future generations. Hydrothermal vents defy traditional notions of life's limits, characterized by extreme temperatures and rich ecosystems. The giant tube worm, Rifsha pachyptela, exemplifies this, growing up to 3 meters and relying on symbiotic bacteria to convert toxic hydrogen sulfide into energy, highlighting the complexity of life at these depths. The vent shrimp and robust vent crabs adapt remarkably to these conditions, showcasing resilience in previously inhospitable environments. Recent research shows that vent ecosystems can be ephemeral, with some lasting only decades due to geological activity, underscoring the adaptability of life. In 2020, a new species of snailfish was discovered near the Azores, emphasizing the need for further exploration of these depths. Yet, deep-sea mining threatens these ecosystems, as companies seek valuable minerals. Mining disrupts habitats and can lead to biodiversity loss, making conservation imperative. Climate change exacerbates these threats, altering temperature gradients and increasing ocean acidity, endangering the organisms that depend on stable conditions. To combat these challenges, marine protected areas, MPAs, are essential for safeguarding hydrothermal vent ecosystems. International cooperation is also vital, as the deep sea transcends borders. As we dive into the magnificent depths of our oceans, we are immersed in a world that feels almost like a science fiction tale brought to life. The landscape is surreal, blackened rocks jut out of the shimmering blue, and plumes of superheated water rise from the ocean floor, creating a dramatic contrast against the dark backdrop. Here, amidst the black smokers, towering chimneys that belch mineral-rich, scalding water, life thrives in ways we've only begun to comprehend. The harsh environment is nothing short of extraordinary. Picture the vibrant colors glowing in the darkness, organisms light up the ocean depths like a galaxy of stars. Bioluminescent creatures, such as the ethereal anglerfish and the enchanting jellyfish, emit their own light, creating a dance of colors that captivates the imagination. Witnessing this spectacle is like entering a dreamscape where science and artistry intertwine. The giant tube worm, Rifsha pachyptela, emerges from the black smoker, stretching toward the ocean currents. Its body, adorned with a plume of vivid red and white, resembles a fantastical flower swaying gently in the tide. Internally, these worms house specialized bacteria within their gills. They rely on these microscopic partners to convert harmful hydrogen sulfide into life-sustaining energy. These creatures redefine our understanding of what it means to be alive, says marine biologist Dr. Emily Carter, reflecting on the resilience of life in extreme conditions. They thrive where most life would perish. Surrounding the tube worms, Enormous clams known as Calyptargina magnifica bask in the nutrient-rich waters, their shells aglow with vibrant hues. They form mutualistic relationships with bacteria, similar to the tube worms, showcasing the interconnectedness of these life forms. Crabs scuttle across the seafloor, their robust bodies adapted to withstand the intense pressure and heat. Vent shrimp, agile and lively, dart amongst the rocks, displaying colors that seem almost iridescent under the bioluminescent glow. The transitory nature of these ecosystems is a poignant reminder of the delicate balance of life. Some vents may last as little as 25 years, their existence dependent upon the geological activity of the Earth beneath. The dynamics of plate tectonics can cause vents to explode, die out, or shift, leading to the birth of new habitats. Understanding this temporality is key to preserving the biodiversity that has adapted to these extreme conditions. Each discovery reminds us of the intricate web of life that exists in these depths, Dr. Carter notes. It's a race against time. We must understand these ecosystems before they vanish. In recent years, advances in technology have allowed scientists to peer deeper into the ocean's abyss. The utilization of remotely operated vehicles, ROVs, and submersibles has revolutionized our exploration capabilities, enabling us to document and study these myriad life forms up close. In 2019, an ambitious expedition off the coast of the Galapagos Islands revealed previously unknown species of tube worms and bacteria, expanding our understanding of hydrothermal vents' role in the global ecosystem. These studies highlight the interconnectedness of life in the oceans and the potential impact of human activities. Yet, each dive into these alien landscapes also serves as a stark reminder of the threats they face. The surge in demand for rare minerals, from cobalt to gold, has spurred a rise in deep-sea mining operations. Companies equipped with advanced machinery descend into these fragile environments, scraping away the ocean floor in search of precious resources. Picture a vast, dusty terrain being disrupted, habitats torn asunder in the quest for profit. The consequences of such actions can be catastrophic. Biodiversity is lost, and delicate ecosystems are irreversibly damaged. Marine conservationists are raising alarms, with experts like Dr. Carter advocating for stricter regulations. We need to safeguard these areas before it's too late. The ocean is a treasure trove of secrets, and we must protect it for future generations. Climate change poses another major threat to these unique biospheres. As ocean temperatures rise and acidity levels increase, the very chemistry of life around hydrothermal vents is put in jeopardy. Organisms that rely on specific temperature ranges for survival find themselves in a race against time. For example, the symbiotic bacteria within the tube worms may struggle to function effectively, leading to a ripple effect throughout the ecosystem. The delicate dance of life here is increasingly threatened by global changes, making conservation efforts more critical than ever. Marine protected areas, MPAs, have emerged as a vital strategy to mitigate these threats. They offer a sanctuary for numerous species and allow ecosystems the opportunity to recover. The notion of conservation transcends borders, requiring international cooperation to establish effective policies and practices. The deep sea is a global commons, and its preservation is a collective responsibility. Agreements like the United Nations Convention on the Law of the Sea, UNCLOS, aim to regulate activities in the ocean, but enforcement remains a challenge. Raising awareness about the importance of hydrothermal vent ecosystems and the threats they face is crucial to garnering support for conservation efforts. The urgency of the situation calls for action. We must advocate for the protection of these underwater realms before they slip further into obscurity. These underwater realms are vibrant and rich in biodiversity, serving as living laboratories of evolution. Protecting hydrothermal vents is essential not only for understanding life on Earth but for addressing climate challenges. The journey into the ocean's depths is also a reflection of our responsibility towards it. As we unveil the secrets of hydrothermal vents, we must commit to preserving these fragile habitats for future generations. In conclusion, nearly 80% of the ocean's depths remain unexplored. What wonders lie beneath the surface? Each dive invites curiosity and exploration. Together, we can illuminate the ocean's hidden realms, ensuring its secrets are cherished for generations to come. The ocean beckons, let us answer its call.